Hello and welcome to another episode of Doozer's Shop. I'll take you over the Brown & Sharp grinder over here. Getting closer. A few things you might notice. I got the tailstock on. I got the Workhead on. That's the tailstock. It was missing a tailstock. I got this one off eBay, and the serial number is really close, and it fits very well. And it's new old stock. I mean, this tailstock was never used. Got the Workhead all cleaned up. I took this all apart, and the inside was full of rubber dust. And I guess this machine used to grind a lot of rubber. Came out of Eastman Kodak in Rochester, New York. So I got that cleaned out, and boy, it was like uncured rubber, so it was really sticky. So I got that cleaned out. Just want to let you guys in on a tip here. This belt, it's like a fabric, rubber-coated fabric flat belt, endless. There's no seam, and if you look on it, it said Panther 400, and then it said 1.25 inches by 21 inches. So what I did is I come across an internet search of New England belting, and I think Berlin, Connecticut. And I talked to a guy, emailed him. The guy's name is Greg, and they have this belt, and they actually listed on their website they created a part number, but it's 1.25 inches by 21, and I told him that, and he's like, oh yeah, that's exactly what they sell it for. Brown & Sharp 13 cylindrical grinder. They sell it for this. So I asked him how much. He's like $28. I'm like, oh yeah. I just bought one as a spare. This one's in fine shape, but for 28, less than $30 there, I wanted to get a spare. Because I didn't know where to get these until I found it on the internet. So getting that going. Another thing I just want to mention, it's got there's a half 13 nut to attach it to the table, and you kind of come around, there's half 13 nuts. This swivels like that. And there's a half 13 nut there, and that's the table nut, and there's another one that tightens the swivel on the back. These nuts, they're like, they're grade like 2 or just soft as can be. And here you have to put your wrench in, an open end wrench to tighten it. Oop, there you go. You put your open wrench because there's just no room at all, and you need an open end wrench with these two. But with the grade 2 nuts like this, I think is just a grade 2 nut. The wrench flats, with an open end, it's so soft the nut, they kind of just get mushed out easy. So I got some. These are grade 5. There's a marking on them. So, cheap thing to do: go to the hardware store, get some good quality grade 5 nuts. So when you're using your open end wrench, you don't mung them all up. So that's with that. Come back here to the grinder head. This is the angle plate that bolts on to the main casting. See the parting line? There's Allen screws, and this is the angle plate, and there's another sub base. Let me go around the back without tripping here. So what the deal is, the motor goes in and out for belt tension adjustment, and if you look, there's here it is, this bolt here. You loosen that, and this whole thing shifts side to side, and the reason it does, and I know I got the shaft out. This is a single pulley, and there's a 3-step pulley on the back. So this thing goes in and out for the adjusting, where the belt lines up on the 3-step pulley. Years ago, and I showed you some of my spindles, some spindles have a triple shiv pulley on the front where you didn't have to do the sideways baloney. But I don't know, Brown & Sharp did that for whatever reason. Maybe they cheapened it up. I don't know. But anyways, this motor, I think it was original to the machine. It's a Doozer, D-O-E-R-R. Yeah. 1 horse, 1,800 RPM. And I was test running it. Just got the wires out. I was test running it on my VFD over there in the corner. And basically, I just had it on the floor. Here, I got another motor I was testing too. There's my other VFD, Pamela Anderson there. that's a 1.5 horse Reliance, and I was seeing if it was maybe smoother than the one I had. That's actually louder, or not as smooth rather. But basically, let me show you on this VFD. They're both kind of have this issue. That's the one I use on my Bridgeport mill, and I just plug it in. This is forward reverse, and this is the speed pot. And I know it's got the factory pot right there. But anyways, that pot, let me back up. The motor was a little jumpy. Oh gosh, how can I say this? It held steady RPM, but it was sort of, it wavered. Like this thing reads out like, 60.3 hertz. In the tenths after the decimal point, it would kind of fluctuate a little. And what it was doing to the motor is it was putting out kind of a little bit of a fluctuating sine wave or something. And what it is, I think, is the pot potentiometer was like, I knew this one was scratchy because you turn it and the Bridgeport spindle would hesitate. But at a steady state, this is a 0 to 10 volt signal. It's hooked up as a voltage divider on the pot, so it's analog, and it converts it to the digital signal for the VFD. It was causing the output frequency to waver a little bit, and it was causing the motor to have vibration, and that's, it was just because the output current was wavering. And then my VFD over here, the same thing. That VFD had the output was not stable. If you ran it up all the way to 60 hertz, it would be. But yeah, I got the pot on here too. So what I did is I got a rotary phase converter that I have up in the attic that runs my outlets here. So this is a 3-phase outlet plugged in there, and when I turn on the rotary phase converter, the two legs are 230 volt single phase, and the third leg is made by the rotary phase converter in the attic, and it generates the additional 2 phases for 3-phase. So when I turn on the rotary phase converter and I plug in my motor directly, it was fine. And I'll show you what I was doing. I was assessing the vibration. I had this motor, and I had another one. I just have it sitting on the floor, and I had the cheater cord wired up. I just had it picked up, and I just put my finger under the edge of the motor, and just feeling the vibration with my fingers. And so I've come to determine that it was the VFD, both VFDs of mine, that was just putting out a wavering signal. But anyways, after I got that sorted out, let me go back to the motor. And the reason I got it taken apart, first of all, this motor, it's in a fairly large case because you can got all this free space in there doing nothing. These windings, they look good and they're shellacked all nice, but I don't think this whole stator assembly was baked in varnish like the higher quality motors are. But it doesn't run too bad. The electrical pulsation vibration is pretty minimal after I got the VFD thing sorted out. So I'm going to get new pots or just convert it to buttons where I can go up and down with the speed. But there is a physical imbalance to the rotor or armature or whatever. I'm going to bring you over to the surface plate, kind of show you over here what I got going on. So I took the rotor out of the motor, and I've been trying to balance it. What I would do, first let me show you, I would spin it up on I'd let the wire wheel on my bench grinder run, I'd hold the bearing in this hand, and I'd hold the bearing in this hand, and I'd push it up against the wire wheel, and it would accelerate it up, and I could test how much vibration imbalance this had. So you see I got some markings on there. The first thing that I found weird, this area, it's like zinc or aluminum cast. I think it's aluminum. It's not concentric with the body. And maybe I can show you here. I got the indicator on it. You might not be able to hear the indicator. Okay, it's touching intermittently, but you can't see the dial. Hear the scraping? It's off a 16th. That casting. This side's good. This side wavers about a 16th. So I marked the heavy spot, which I thought was the heavy spot, and then the light spot is, well, what I thought was the, anyways, I got to playing with it. And these little nubs are actually balancing nubs. You can take them away, or if you get to lighten it up, or you can put weights on them, like little washers, and peen them over. So what I did here, this is a 1032 nut, and it's almost 3/16. So I screwed it on there by hand. I mean, you can put on a different one. I'm not really threading it more than just kind of cross threading it on no threads at all to try and find the heavy point. Now, what I got going, there's the bearing on the shaft in a V-block. And this brown thing is just a piece of, I don't know, zinc or something. It just sits on there, and the centering of it is kind of controlled by the bearing being square in the V-block. It just knocks it off. But this side, right there, it just sets on there. So any imbalance, and I don't know if I can show you. Put the camera there. Probably can't see the focus of it, but it wavers back and forth. You have to trust me on that because this camera, okay. Basically it does this. It goes, when you spin it, it kind of does that, and it shows the vibration. That's kind of how the Stewart Warner balancers work, is they have a set of roller bearing V-blocks. This is in the motor shaft bearings. They have V-blocks with bearings, and the V-blocks are on linear slides that can actually move back and forth. And they drive the motor with just a flat belt, or the rotor rather, with a flat belt, as not to induce, just really loose, not to induce any influence from the test of the spin balancer changing the vibration characteristics. And they'll spin it up, and it's timed with sort of a strobe light or something, and they'll move back and forth. And they do this with crankshafts, with automotive engines and everything, unlike a Stewart Warner type balancer. So, long story short, I'm going to keep playing with this, adding weights and spinning it. And then what I'll do is, I'll grab this bearing, and I can't do it with the camera. I'll hold this in one hand, I'll hold that in the other hand, and I'll spin it up on the bench grinder. With the wire wheel just makes traction on here, and it can spin it like 3,000 RPMs, and sometimes it will go the other direction. I don't think it did it now, but that's the idea. So there was an electrical problem with my current coming out of the VFDs, and there's an actual physical imbalance with the armature or rotor, whatever you want to call it. But I guess this is a pretty good motor. The windings aren't varnished, dipped as a final bake process, but it's not bad. 1 horse, 1,800 RPM. Control box was over here, and I just installed it the other way, and then the motor shaft, I'll install it coming out this way, because I don't like the motor control breakout box against in here. I like it more accessible. So anyways, that's just a quick update of what I was trying to accomplish here with this motor on the 13 surface grinder, cylindrical grinder, sorry. And I'm going to try and play around this afternoon and get some more balancing done. And if I can't, I'll just take it to an electric motor shop and let them balance it for me. Hopefully I can get it done for a reasonable price. But until next time, this is Doozer Shop.